Hello. All right. So hello everyone, and in this video we'll be performing more operations on linked list in JavaScript. So in the last video we have covered append operation. That means we added a new node at the end of every linked list. Then we also performed the print operation, in which we printed the whole elements of the linked list, okay, the complete linked list. So these were the two basic operations which we have covered before, so you can watch my last video. If you don't know where is it, you can just visit Geeks for Geeks practice channel first. It will open up something like this. Then in the playlist section you will find that we have a complete playlist for data structures using JavaScript, so you can check out this, and it's totally free. You can check out the whole playlist. Every topic for data structure is covered here, okay, just data structure. I'm not talking about algorithms right now, so you can check out this playlist. For algorithms we might bring some separate playlists, okay, so just wait for that. But yeah, you can see every data structure has been covered here. Do follow this, and if you are referring this for some other language, you would still feel that yeah, this is much easier than some other language. If you are trying to learn data structures in some other language like C++, uh, learning data structures in JavaScript is way more easier, because there are much less restrictions and the syntax is very much easy. So if somebody is learning DSA for web development, like if you are a good developer and you want to excel more, then you can learn data structures in JavaScript. Okay, so you can do check out this playlist, and here all the things are available. And what I was talking about is, you can see that we have linked list video, so it was covered yesterday. You can check out this one, so it covers all the basics, and how a linked list is made in JavaScript is covered in this video. Okay, so right now we are in operations on linked list part 1. So what we'll do in this video is, we'll be performing insert in between operation. Okay, yesterday we will be yeah, yesterday we were performing the append operation. That means we were adding things at the end of the linked list. But today we'll be adding things in between of a linked list, okay, at some specific target. And then will also perform the prepend operation. That means adding things at the first of the index, okay, at the first of the linked list. So we'll be performing the prepend operation, and also we'll be performing the delete operation. That's how we can delete a node, and how we can rejoin the linked list with removing the deleted node and then relinking the skipped. Okay, so we'll do that. So these are the three operations which are going to be covered today, and in the next video we'll be learning about separate kinds of linked list which are available. Like right now we are working on singly linked list, but we have doubly linked list, and then we have circular linked list. So we'll see that in the next video. Alright, so let's begin. And before starting, in the live chat you can see that we have a link provided by Geeks4Geeks, or you can check out the description also. So if you visit that link, it's actually for a course of DSA, and it's a paid course. So if you want to purchase it, you can, because it covers everything from beginner level to advanced level which is required for DSA in JavaScript. Alright, so you can check out its content first, and it's really helpful, not just for JavaScript. If you are trying to learn in any other language later on, you can still find things similar. Okay, so yeah, now let's continue. So what I'll do is, now I will explain how we'll be writing code for that. So first of all, we'll be opening whiteboard for that. We'll be drawing some figures for that, so that we get a better idea how we'll write code. Okay, so I'll just close it, and let's open whiteboard. Okay, fine. All right. So we have covered the singly linked list. Okay, so I'll just write linked list here. Okay, singly linked list. So linked list. Fine. So in linked list, we have covered two operations. Number one was I think I can write it here. Number one was append operation. Okay, append operation, which simply means that we are actually adding things. Suppose you have some elements in your linked list in this order. So append simply means adding new element at the end of a linked list. Okay, it's like that. So you can insert a new node at the end of a linked list every time you want to add. Okay, so we have covered this. Then we have covered the print operation, which is really helpful for printing the linked list. Okay, for printing the linked list. So I'll just write print or display. I think I've named it display, but yeah, still mean the same. So print operation. This was also covered in last video. It simply traverses the whole linked list and prints the values, prints the nodes. Okay, now today what we are going to cover is we will cover two more different things, actually three different things. Number one is prepend. Okay, so we have covered the append. We want to prepend, that means we want to add a new element before this, before the starting of the linked list. Okay, that means the first element now becomes this. Okay, now becomes this. It's like that. So we'll be performing the prepend operation. So I'll just write it here. So the third operation is the prepend operation. Okay, third operation is the prepend operation. Then the fourth operation is insert between. Okay, insert between simply means it's just like the append operation, but it requires one more parameter, not just the data but also the target location. Suppose you have a linked list. Okay, let me just first write it. Insert in between. So this is a little bit more complicated operation, but yeah, it's still easier. Okay, so what we'll actually do in this is, suppose you have this linked list. Okay, this linked list, and I want to insert X here. I want to insert X here. Okay, that means in between of a linked list. Okay, so what will I do is I will simply get the details of this one also. Okay, after which I want to add a new element. Okay, so I want the details of this index also. So I'll call this, I'll provide this, that suppose I want to add 20 after 3. Okay, that means suppose this is 3 and I want to insert 20, that is X. Okay, so what I'll simply do is I'll just provide 3. Okay, and I'll say that after 3 you have to insert 20. So we'll be creating a function for insert in between. Okay, so similarly we have one more operation, that is the delete operation. So delete operation is very same as the insert. What you would simply do is you would find the target. Okay, first of all you would need the target. Okay, suppose the target is X, so you would just find it and you will just remove it. You will just remove it and then you will rejoin this linked list. Okay, rejoin this linked list. Okay, so we'll see that how it works actually. So delete operation will work like that. Then we have I think, yeah, we have covered all. Okay, these three operations will be covered today. Okay, so let's continue. And now what I'll do is I'll just erase this first and I'll explain one by one all operations. That is the prepend operation, then we'll be performing the insert operation, then we'll perform the delete operation. Okay, so let's begin. All right, so let's write the first one, which is simply prepend. Okay, prepend operation. So in this, you can assume a linked list, like you have some elements here. Okay, I hope this works. Yeah, so I would say that this is, suppose, my linked list, some random position, some random memory blocks, because linked list is not dependent on contiguous memory location, it just need some memory locations. Okay, suppose this is my linked list and suppose the first element was 1. Okay, suppose the first element was 1 and you are pointing to this. Okay, this is some second address and some second data. Okay, and similarly it's pointing to some third location, so it's having value 3 and it's pointing to some other location and it's having value 4, and obviously since it's the last it will be pointing to null. Okay, so this is a very basic linked list which I have created, and you can assume this address as x1. Okay, that is, it's pointing to x1 address, this 2 is x1, and then again 3 is located at some x2 address. So I would say that 2 is actually pointing to some x2 address, that is the location of 3 is x2. Okay, what I'll do is instead of this I'll write the numbers better. It's better. So I would say that it's pointing to some location x2, and then it's pointing to some address x3. That means the address of 3. And then this 3 node is actually pointing to some address 4, that is x4. Okay, so you can see that the next will be containing these addresses where this node will point to. Okay, so this is covered in the last video, so you can watch that. Now what happens is you want to prepend. What happened in append? You inserted a new element here, that is in the last. But in prepend, you will simply insert a new element before. Okay, some new element here. Okay, prepend simply means that. So how we'll actually perform prepend here? Okay, so prepend is very easy. First of all, in the last video we have actually created a head. Okay, a head. So initially head is actually a pointer which will always point towards the first element. Okay, always points towards the first element. So what we'll actually do is we'll simply add the new node. Okay, what we'll actually do is, first of all, you can assume the address of this one is x1, right? This node is at some address x1, right? And it has two values, 1 comma x2. That means x2 is address of some next node. So the address of this is actually x1, address of this is actually x1. Fine. So what we want is we want this address, and we will be given some data as an input. So what we'll actually do is, how to get this address? This address simply is gotten by this head. Okay, wherever is head pointing to is my first node, and from that I can easily find the address. I can easily find the first node by the head. Okay, so what I'll actually do is I'll use the head for finding the first address. Okay, since I found the first address, what we'll now do is we'll simply replace it. Okay, right. So what we'll actually do is we'll first of all create a new node. Okay, we'll first of all create a new node. So let me just create a new node, and it has some value, suppose 0 point, okay, let's make it 0. Okay, it has some value 0, and what I'll do is I'll just make a node here. Okay, I'll just make a node here, and then let's join this. Fine. So this is a new node. We have created a new node, but we need to now join this. How we can join this? We'll simply call this head. We'll simply call this head. Just remember, right now head is pointing at this one. We'll simply get the node of this head. That means we'll get the one. We'll get one, and we'll simply say that this new nodes is having actually a data as 0. Okay, data equals 0, and its next is first of all null, because we created a constructor for a node which is actually having a next value as null. Okay, because right now it does not have any neighbor, it's not connected to any linked list. We just created a node. What we'll actually do is we'll simply remove this null, and we'll simply pass on whatever value is available in the current head, this dot head. Okay, this simply means I am giving the value of 1. Okay, whatever is the one node, I'm actually pointing towards the one node. Okay, this head is actually pointing towards the one node. What I simply mean is, since I change this next to 1, okay, it will simply point towards this one. Okay, it will simply point towards this one. Yes, so it works like that. And now, since now I'm pointing towards 1, what I'll actually have is, you can simply assume that I am having address x1. Okay, because I am pointing towards 1. Address of 1 is x1, right? So now I'm pointing towards 1. This 0 is having next as x1, right? So that's how you will be performing the prepend operation. Now you have performed the prepend operation, you also need to move this head. So what you'll actually do is, now you will just remove this head from here. You will just remove this head from here. Okay, head will always be at the first element. Okay, that means 0 is now the first element, so we'll be pointing the head towards the 0. What I simply mean is, you'll simply say this dot head equals whatever new node you have created. Okay, so I'll just say new node. Okay, so that's how you can actually work here. So now what will happen is, you are simply pointing your head here. Okay, head is now actually pointing here, new head. Okay, new head is actually pointing here, and the head is now removed from here. Okay, I hope you got this. That's how you will be performing the prepend operation. Now prepend is done. Now we need to perform one more operation, that is the insert operation, very important. Okay, so I'll be drawing the insert operation here. Okay, so let's name it as insert. Insert between the linked list. Okay, fine. So again, you can assume a new linked list, and I'll just say that we'll be drawing some shapes here. And you can assume that this is my linked list. Okay, this is my linked list. So let's say that this linked list is having value, the first value is suppose 1, and second value is 2, and third value is 3, and it's pointing to this one, it's pointing to this one. Okay, insert in between simply means, suppose I want to add some value 1.5 here, so this is simply the insert in between. So what will I actually do is, I'll simply say, suppose I want to insert 1.5 here. Okay, 1.5, I have a new node, I'll create a new node 1.5. Okay, I'll create a new node 1.5, and what I'll actually do is, I'll change the next of this to this. Okay, I'll just point here. Okay, I'll just remove this, that means I'll just erase this, and I'll say now the next of 1 is actually pointing to 1.5, and also the next of 1.5 will be pointing to 2. So that's how you can insert in between, very easy. You can just break the chain and then add an element in between, and then you can change the pointers. Okay, so you can see nothing is changed here, but still things are fine. Okay, so how we can actually do this? It's very easy. First of all, you need to find the exact location where you want to insert. Okay, for example, I'll just remove it first so that you get a better idea. Okay, so I hope you got the operation of 1.5 insertion in between, but let's take some other example. That is, I want to insert an element 2.5, a new node 2.5 between here. Okay, between here. How can I actually do that? So for that, let's draw this in blue. Okay, 2.5. Fine. I want to insert this new node. So first of all, you created a new node, right? A new node has been created, and you would say that the data of this node equals 2.5, and its next is equals null. Similarly, the data of this is data equals 2, and next, okay, next equals it's pointing to 3. Okay, some node 3. Okay, it's like that. So now what I'll actually do is, I want to change this next to 2.5. Okay, that means this next of 2 will be pointing to 2.5 instead of 3. Okay, what I want to do. Okay, and similarly, yes, I would say that the next of this new node will be now actually pointing to node 3, and this must be pointing to node 2.5 whenever I'm trying to insert in between, right? That's why what I want to do, node 2.5 and node 3. Okay, that's what I want to do. So how we can do that? So first step is you would first of all find that specific target. Okay, so whenever we are performing the insert operation, we'll be creating a function. Okay, so I'll just name this function as, suppose, insert after. Okay, insert after, suppose this is my function, right? In this, I'll provide two parameters. First of all, what is the target? Okay, after which I want to insert my data. So my target is 2 here, so I'll just say target, and let's say it's equal to 2, and then my second parameter is the data which I want to insert. Data is 2.3, right? That's how we'll be performing the insert operation. So for this, I'll just draw a line here. So for this, what we'll actually do is, we have provided a two parameter. So we'll be, you can say that the head is pointing here, right? Head is pointing here, right? And also the current pointer is also pointing here. Okay, so we have created a current pointer in the last video for iteration. Okay, so initially the current will be pointing here. I'll check that if the target equals current dot data. No, it's not equal. So again, I'll move the current pointer. Okay, I'll move the current pointer to here. Okay, current pointer is here. So again, I'll check that is the target, that is 2, equal to current dot data, that is current dot data is actually 2. So what I'll do is I'll compare both of them. So you can see target is equal to current dot data, so I will be performing insertion after this value, after this node. Okay, so I hope you got this. So current is now pointing here, and after this I want to perform insertion. Now we have the data, okay, we have the data. So what do we need is, we have got the target. Simply create a new node, I would just say that if I talk about this, c dot next, okay, that means its next is what? Next is equal to node 3, right? Node 3, and data is 2, current dot data is 2. Fine, but now you can see this current's next node is 3, right? Next node is 3. So what I want to do is I want to perform 2.5. I want to add 2.5. So this current will be still the same, don't worry about that, but we have created a new node 2.5, and its next is now not pointing at null, it's actually now pointing at node 3. Node 3, okay, node 3, that means some address. So it will simply point like this. Okay, right now I haven't removed anything. You can see 2 is still pointing at 3, but now 2.5 is also pointing at 3. Okay, it's like that. We have created a new node 2.5 and it's pointing at 3. Now we need to just remove this link. How we can remove this link? I would just say that this next, after performing, I'll just say c current dot next will now be equal to new node, that is 2.5. Okay, I hope you got this. So it simply means that now this link will be removed. Okay, this link will be removed, and this 2 is now actually pointing to this new node. Okay, I hope you got that. It's very easy. Okay, that's how you'll be performing the insert operation. Okay, so this is the logic for insert operation. You can rewatch this. If you didn't understand what I did, you can still ask me. I'll just repeat the things. Okay. Hello sir, after completing each chapters, please solve lead code and GFG problems. Definitely, I'll try to solve competitive programming questions, but what I was thinking was, after this we might cover the algorithms part, but some basic questions can still be done by using basic JavaScript and DS. But yeah, we'll be bringing videos on that too. All right, so yeah, we have performed the insert operation. After this, one last operation is remaining, that is the delete operation. Okay, so delete is very easy and it's similar to the insert operation. Okay, so let's write that. So the third operation which we are performing today is the delete operation. Okay, so delete a node. Okay, so in this we'll be actually creating a very basic function. In this we will be needing only one parameter, that is the data which you want to delete. Okay, right, the node which you want to delete. So let's say that we have a function here. We'll be saying that we have a delete node function here, delete node function. Inside this, somebody provides a data like 3. Somebody wants to delete through a node 3. Okay, so how it would happen? What I'll do is, instead of this, I would take example of 2.5, since we have built last diagram and we have inserted 2.5 in between. Okay, so I'll just copy this. I'll just copy this. Fine. And I will paste it here. What happened? Okay, just a minute. Yes, fine. So now you can see again we have the same linked list. Okay, we have the same linked list, but now we want to delete this. Okay, we want to delete this. So I'll just change it a bit so that we get a better idea. So I'll just remove this. I'll just remove this. And suppose you wanted to perform delete in this 2.5. Okay, this is my linked list and I want to perform delete in this 2.5. So what actually must be done is you would just change the next of this 2 to this 3. Okay, and then you will just remove the connection. Okay, you would just remove the connection. That's it. That's all. That's what you need to do. Okay, that's what you need to do. Okay, so automatically this 2.5 will be removed. That's how you can perform the delete operation. How it will be done? Very easily. Again, I'll draw the same diagram. Okay, this is the current situation without deleting. First of all, you would need to find the data which you want to delete. Okay, so what I'll do is I'll just say that my head is pointing to this. Okay, head is pointing to this, and also my current is also pointing to this initially. Then I'll just check that is my current dot data is equal to this target. No, it's not. 1 is not equal to 1. 1 is not equal to 2.5. So I'll again move the current. Okay, I'll just move the current. Okay, now the current is moving towards the next one. Okay, current pointer is pointing to this one. Now I'll check that current dot data, that is 2, is equal to target, that is 2.5. No, it's not equal. So again I'll move the current. I'll just move the current. Now the current will be actually pointing here. Okay, current will be pointing here. So I'll check that current dot data, that is 2.5, is equal to target, that is 2.5. Yes, both are same. So now we are at the correct place. Okay, correct place. So current is pointing to the correct deleted node. Okay, which we want to delete. So now what we want is we want to delete this node. So first of all, okay, actually, we did a mistake here. We did a mistake here. We don't need to provide current. We don't need to push current here. Current here. What we'll actually do is, again, you are here. Okay, you are here. What I'll actually check is, okay, let's start from the beginning. Initially, the current will be pointing here, right? Current will be pointing here. So current dot next is equal to 2, right? Equals to 2, and that next, okay, after 2's next, it will be actually pointing to 2.5. Okay, it's like that. So things are actually working like that. So what I actually want is I would simply check that currents next is equal to 2.5 or not. That's what I want to check. No, it's not same. It's not same. So I'll just move the current pointer. Okay, so that's what we are going to compare. So what I'll do is now we need to again move the current pointer. So the current pointer is now actually pointing here, and its next c dot next is actually equal to my target, that is 2.5. So this is the correct node which we want to perform. So now you are in this node, you don't want to delete this node. You can see we are at 2, we want to delete 2.5. You don't want to delete 2, okay, but you are at 2, current is at 2. Now simply you would just say that this current dot next must be equal to 3. Okay, current dot next must be equal to 3 to delete things. So what I'll simply do is I would write C, I would just write C dot next is actually equal to C dot next dot next. That's it. That's very easy. So dot next of next will actually be equal to 2's next is 2.5, 2.5's next is 3. Okay, so now I've just changed this C dot next to 3. Okay, that means now C dot next is not pointing to this. Okay, now C dot next is not pointing to this, it's directly pointing to 3. Okay, I hope you got this. This is done very easy. Now you can simply ignore this because it will be there, but yeah, you can ignore this because there is no way you can get here. Okay, there is no way you can get to 2.5. So that's how you can actually break the things, and that's how delete operation is done. Okay, so this can be now considered as neglected because nothing is pointing to this 2.5. Okay, you can't go to this 2.5 at any case. Okay, so that will be automatically ignored. All right, so that's how you can perform a delete operation. It's very easy. You'll just say c dot next equals c dot next dot next. That's how you can write the delete operation. All right, and suppose Suppose there is a situation, you want to delete the head. You want to delete the head. Okay, let's write this again. Suppose I'll just remove this. Okay, fine. We have a situation, very important case, because suppose sometimes anyone wants to delete the head. Okay, so again, now the current situation is this. Okay, current situation is this. You can see that the new linked list is 1 2 3. I want to delete this one. How can I do that? I don't have any node before that. Okay, in the 2.5 case I had a node 2 before that, but in the case of head I don't have any node before it. How can I do that? Very easily, you just need to say that if first of all, you'll always check whenever we'll be performing the while loop for moving current. Before that, you'll check that if this dot head will always be pointing to the first node. So I'll just say this dot head dot data is actually equal to my target. That means I want to delete the head. Okay, it's actually equal to my target, that is 2.5 suppose, or in this case I want to delete one. Okay, so I'll just say that now I want to delete one. Okay, so instead of 2.5, now one will be here. I want to delete node 1. Fine. So this is the case. This condition will be true if this dot head dot data equals target. That means data is 1, which is equal to my target 1, right? Same. So what I'll actually do is I'll just say move this head pointer to the next. Okay, so what will actually happen is this dot net current head, okay, this dot head will be now pointing towards the next node. Okay, will now be pointing towards next node. So this dot head dot next. That's it. Very easy, very easy. Okay, so you can see that's how you'll be performing for the head operation. Like if you want to delete a head, that's how you can move the head, and automatically this won't be available. This won't be available. So after this, automatically head won't be pointing here, so you won't be starting with this first. You will be actually starting from here. Okay, this will be automatically ignored. One will be automatically removed. So what I've actually done is I wanted to delete one. I would simply move this head. I would simply move this head to the next position here. Okay, here. So head is actually here. So obviously whenever you are performing any operation, you are always starting from the head. You are always starting from the head. So automatically this one will be ignored. This one will be ignored. The link will be automatically ignored, because obviously head is not starting at 1, so you won't ever start with 1. You will always start with 2. It's like that. Okay, so head will be now pointing at this 2, and now you can again perform the same things again and again. So that's how you can actually delete a node in a head, and also you can delete any node from between with the previous example of 2.5 which I gave before. Okay, so now we'll be writing code for that, very simple code, and let's open VS Code for that. So in the previous video, we have actually written two operations which were append and display. Now we will be performing three operations, that is prepend, delete and insert between. Okay, so let's write code for that. Rekha Kumari, nice work. Thanks. All right, let's continue. First of all, we'll be writing the prepend operation. All right, so very easy. Prepend operation was what? Let's recap. Prepend operation was this. I have explained. I've simply inserted a new element at the first, and then I have changed the head towards the new node, and also this dot heads next is now changed to 1. Okay, we'll see that. But yeah, we have performed this, and you can rewatch this video if you still don't know the prepend operation, and if you still feel the difficulty in the prepend operation, you can still ask me on the live chat. All right, so what you want is, first of all, in the prepend operation, we are creating a new node whose data is something and its next will be null. we have created a new node. So we'll just do that. So we'll say that prepend, and somebody will always provide a data. And what somebody wants is, if somebody is performing the prepend operation, they want that the new data, new node, will be actually now the first index, or you can say the head, and then the linked list will be continuing. Okay, so we have performed that. So we'll be writing code for that. So I'll just say that first of all you'll be creating a new node. Okay, and you'll just say that, yeah, create an instance of node. And what it will actually do is, suppose I want to insert 0. Okay, suppose my linked list is already, okay, you can say suppose my linked list is already 1 2 3 4. Okay, it's like that, and I want to insert 0. Okay, I want to insert 0, but it's a prepend operation, so 0 will be actually added here. Okay, data is 0, 0 will be actually added here. It's like that. If it was append, 0 would be actually added here. Okay, I hope you got this. So that's how you would be doing things. So now in the prepend operation, first of all you have created a new node. That means somewhere separately you have created a new node 0. Okay, and you can assume that 1 is actually pointing to 2, 2 is pointing to 3, and 3 is pointing to 4. Okay, it's a linked list, but you have a new data 0, and it's actually pointing to null. It's actually pointing to null, you can say. It's actually pointing to null. And yeah, let's write this way. Okay, yeah, that's fine. You can see 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4. This is our old linked list, and I want to prepend 0, which is actually pointing to null, because we have created a new node. Whenever you create a new node, what we did was we created the data, like this dot data will be actually equal to 0, that this dot next will be equal to null. Okay, that's what things happen. This dot data equals 0, this dot next equals null. Okay, I hope you got this. Now we have created a new node. Now we want to perform the operation. So I would simply say new node dot next would be actually pointing towards the head. Previous head is what? 1. So actually what I did was, I would just say that 0 will be now pointing to this one. Okay, so now 0 is pointing to 1, but 1 is pointing to 2 3 4. That means this linked list is automatically connected to the above one. Okay, so that's how things will work. So now what we have done is this. Okay, this is done. But one more thing, currently head is pointing to 1, because 1 was the first element in the previous linked list. We actually need to shift this head to this 0. Okay, so for that we can simply say that this dot head will be actually equal to new node. Now the head is pointing to 0. Okay, previously the head was pointing to 1, now the head is pointing to 0. Very easy, prepend is done. Okay, so that's how you can perform the prepend operation. So what I would do is, now let's first of all print this. Okay, let's first of all print this. So I'll just say that you can see that the first element is 1, then 1 is pointing to 2, and 2 is pointing to 3, 3 is pointing to 4, like that. Now I will add 0. Okay, I'll prepend 0. So I'll just say my linked list dot prepend 0. Let's see what actually happens here. Okay, so you can see that 1 is pointing to 2 3 4, and 4 is pointing to 5. Let's run this again. Now you can see we have the first element as 0. Okay, and you can see that 0 is pointing to 1, 1 is pointing to 2, 2 is pointing to 3, and so on. Okay, so that's how you can get the values. And suppose if you want to get the current head, you can say get current head. Okay, so you can simply print the value of head. Okay, you can simply print the value of head. So before that I would just call this console.log current head, and after this also I'll be calling the current head. Okay, let's see what actually happens here is, my bad. All right. Right, so you can see that. Now let's try to see where is the current head pointing to. I've just removed this display so that we can just see the heads. All right, so let's run this again. So now you would see that previously the head was pointing at 1, but now it's pointing at 0. Okay, so you can see I printed at both cases. So before adding 0, before prepending 0, it was actually pointing at 1, but now the head is pointing at 0. Okay, I hope you got this. Now we perform the prepend operation. Now we'll be performing the delete operation. Okay, so for that I'll again go here, and here you can see that, yeah, let's perform the insert between operation, then we'll perform the delete operation. Okay, so what insert does is, if you want to insert a new element, you can actually see that things are pretty much same. You just need the current index. Okay, current, after which you want to add new data. Okay, so in insert we needed two parameters. First is the target. Okay, target simply means after 2 I want to insert a new data, that is 2.5. Okay, so we want to find the target. So first of all I'll just find the target, then we'll be performing the different operations. Okay, so I'll just say insert, and let's name it as insert after. Okay, and then you would just say that you need first parameter as suppose the target. Okay, you would need the first parameter as the target, that is after 2 I want to insert something, so the target is 2, and then you need to insert something, that is data 2.5. so after 2 I want to insert 2.5. so you can actually assume that the current state is actually 1 is pointing to 2 and 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5. Okay, this is my current linked list. What I want is I want to insert 2.5. Okay, I want to insert 2.5 in between this 2 and 3. Okay, so what actually happens is I would just provide this 2, and after 2 I want to insert 2.5. Okay, so target is 2, data is 2.5. Okay, so now inside this you simply need to create a new node. Okay, so very simply you just copy this. Okay, just copy this. You have created a new node, just copy this and just paste it here. All right, so you have created a new node 2.5, which is actually pointing at null, pointing at null. What I actually want is I want this 2 to point at 2.5. Okay, that means what I actually want is I want this 2 to point at 2.5, and this 2.5 to point at 3, and 3 was already pointing at 4, and 4 was pointing at 5. Okay, so this will be the actually insert operation. Okay, so you would first of all break things. Okay, so initially so you can say before case is this, before case is this, but after insertion this will be the case. 1 will be pointing at 2, 2 will be pointing at 2.5, 2.5 will be pointing at 3, 3 will be pointing at 4, 4 will be pointing at 5. So you just need to perform this operation, these 4 cases. Okay, you will just change the next of 2 to 2.5 and next of 2.5 to 3. Okay, I hope you got this. First of all you need to find the current. Current will be what? You will check that is this 0 equal to my target? No, 0 is not equal to 2, so I'll just move this. Okay, again I'll check, is this 1 equal to my target? No, 1 is not equal to my target, so I'll again move. I'll then check that is this 2 equal to my target? Yes, 2 is equal to 2. After this I want to perform insertion, so 2 is equal to my target, so current is now actually pointing here. Okay, so I would simply say current must stop here, because after this I want to perform operation, right? So current will be actually pointing here, right? Current is actually pointing here. So simply do one thing here. I would find the current. Okay, so I'll just say initially the current is always starting from the head, that means it will be starting from the first element, right? Now we want to perform the current we'll be finding the current in which we want to insert things, after which we want to insert things. So I'll say that initially current is this, but it's not equal to my target, so I'll just append, I'll just increment the current. Okay, so here I'll just say that while current, I'll be creating a loop here. Okay, and I'll just say that if my current dot data, that is initially you are at 0, 0 is equal to 2. Okay, 0 is equal to 2, then you will be performing this, else you will increment, you will change the current to the next value. So first of all 0 is not equal to 2, so you will increment. You will check 1 is not equal to 2, you will again increment. Okay, that's how things work. So if things are not equal, you would just increment. Okay, you are incrementing here. Okay, so you would just say that current dot next, current equals current dot next. Okay, current equals current dot next, that means you have incremented the current. Okay, now this will work till 2, because at 2 you would simply check that current dot data 2 is equal to target. Yes, current dot data is equal to target. This is the true case for value 2, because 2 is equal to 2. Okay, so now we have this. I would just say that 2 equals 2. Okay, we are at 0, we would just increment it, then after 1 we would just increment it. Now we are at 2. Current dot data is actually equal to our target, actually equals to our target. Okay, for your convenience, I would just say that target equals 2 and data equals 2.5. Fine. So you would just check that is this 2 node equals to this target. Okay, this current dot data 2 is equal to target. Yes, it's equal. So now we are inside this. Okay, so now we are inside this. You just say that our new node, that is 2.5, which we have created. Okay, 2.5 which we have just created. Okay, so what I simply mean is we have created 2.5, right? 2.5, but it's pointing at null, right? It's pointing at null. You can see that after this 2.5 has been created, but it's pointing at null. What I would do is I'll just say that currents dot next is what? Currents dot next is actually equal to 3. So I would just say that it will be pointing at current dot next. Fine. That is, finally, it will be actually pointing to 3. It will be actually pointing to 3. Fine. We have done this. One more thing. I would just say that my current dot data, no, sorry, current dot next. Okay. Yes, current dot next is currently equal to 3, is equal to 3. But now I would just say that current dot next is actually equal to 2.5. Okay, that's how we'll be shifting things. So current dot next equals to 2.5. That means it simply says that now 2 is actually pointing to 2.5. Okay, things are actually working like that. Okay, so I hope you got this. That's how we'll do things, and that's how I have explained in the diagram. You can see that what I have done is I would first of all change this 2.5's next to 3. Okay, that means current dot next. Okay, sorry, here. What I've done is I've just changed this next 2.5 pointing to 3. Okay, that means simply you can see that initially 2 was pointing at 3, but now we have created a new node 2.5. I would just say that current 2.5, its next is what? Its next is 3. Its next is 3. So for the new node, I would just say that new node's next is equal to current dot next. That means new node's next is now actually equal to 3. Okay. Now what would happen to 2? I would just say that current node's next, that is 2's next, will be what? It must be the new node. Okay, 2's next now will be equal to new node. Okay, that means 2 will be pointing to 2.5 very easily. Okay, so here since you found the target, you would just say that new node's text and new node's next is actually current dot next. That simply does one thing. 2.5 will be pointing to 3, right? I'll just say that current is actually 2, right? Current is at 2. What I did is its next equals 3, right? Its next equals 3. So what I did was new node's next will be now pointing at 3. Okay, 2.5 is now pointing at 3. Alright, so one more thing must be done. What must be done is current dot next equals new node. That means 2 must be now pointing at 2.5. Okay, so we actually made a link like this. Okay, we actually made a link like this. So what would happen is simply before this I would just write the before state here so that you get a better idea. Before this, things are like that. Things are like that. Now after this, I'll just copy this again, and here we actually have a new node 2.5 which is actually pointing at 3, right? And 3 is pointing to 4, 4 is pointing to 5, right? This is the new case. What would happen to 2? 2 would be pointing to 2.5 and 3 would be pointing to something like that. Okay, so 2.5, 3, 4, 5, it's like that. So now again we'll be starting from 1. So the after case is actually 0 is pointing to 1, 1 is pointing to 2, now 2 is pointing to 2.5, and 2.5 is now pointing to 3, and so on. Okay, it works like that. So operation is very much performed here, and now you can actually check the displayed items. Okay, so let's try to display things, and we would just say that suppose this is our linked list, right? And we'll just say that let's try to perform insert after 2. We want to perform 2.5. Okay, let's write that. So let's print this, and the problem here is, I think let's try to print this again. Yes, so now you can actually see that after 2 we have 2.5. Okay, 2 is pointing to 2.5. Okay, 2 is pointing to next node, that is 2.5. Now 2.5 is pointing to 3. Okay, so that's how link has been created between these. If you still didn't understand what actually happened here, is you can just rewatch this video. And one more thing, uh, if you still don't know how insert is performed, you can ask me in the live chat. All right, so we have simply performed the live insert operation very easily. What I did was 2.5 is now pointing at 3, 2 is pointing at 2.5, very easy. Okay, now after this we need to perform the delete operation. Okay, so the delete operation is very easy. And what I did was, in the delete operation we had two cases. One was, if I want to delete the head, we would simply shift the head to the next value. Okay, that means if I want to delete one was the head, I would simply shift the head to 2. Okay, one will be automatically ignored, right? And if I want to delete any element in between, that means I have some target, I want to delete this 2, I want to delete 2.5 which we have created. I would simply go to that target and I would just remove the link. Okay, I'll just rewrite things here so that you get a better idea. So let's suppose you have this case, 1 is pointing to 2, 2 is pointing to 2.5, 2.5 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5, right? This is the case. Right, this is the case. Suppose we are here and I want to delete this. I want to delete this 2.5. How would I actually do this? I would just go here. I would just go here. I would just go this, add this 2. I would check that if it's next, current dot next equals to the node which I want to delete. Yes, it equals to 2.5, and this is the correct case. So initially the current will be pointing here and its next is not equal to 2.5, so I'll just remove this. Then I'll again move the current to 2 and its next is equal to 2.5. So yeah, we are correct, we are at correct node. Now since I want to delete 2.5, I would simply check that if one thing can be easily done is, I would just say that current dot next is 2.5. 2.5 is pointing at what? 2.5 is actually pointing at 3. So I'll just write here c dot next, c dot next is 2.5, and that 2.5's next is actually 3. Okay, so now what I'll actually do is, I would just make this 2 point at c dot next dot next. Okay, c dot next dot next. So what I would do is, once you point this to 3, you would just don't have this link. Okay, since any pointer can point at only one node. Okay, so what I did was, I would just say that c dot next is equal to c dot next dot next. Okay, this is the case, this is the case. Okay, so I'll just write it more beautifully. So here you just need to perform one operation. First of all, reach the target location, then you just say c dot next equals c dot next dot next. Okay, so automatically now 2 will be pointing to 3 and 2 won't be pointing to 2.5 because c dot next can only have one value, right? So 2 will be pointing at 3, 2 won't be pointing at 2.5. Automatically this will be done and this will be ignored automatically. Why it will be ignored? Because there is no way you can reach 2.5 at any case. Okay, so this will be automatically ignored. Okay, this will be automatically ignored, right? Ignore this. Alright, so this is the operation if you want to delete in between, and if you want to delete the head, you would simply do one thing. You would just shift this head to here. Okay, so the head will be actually pointing here, so automatically this will be ignored. Okay, this will be ignored, this link will be actually broken. Okay, this will be ignored. Alright, so that's how we'll be doing things. So let's write code for that. Again, I'll just copy this. Okay, I'll just copy this and I would just write this. Okay, so first of all, you would say that you have the target as 2.5 because you want to delete 2.5, right? You want to delete 2.5. Now Now you want to delete 2.5 and the current will be starting from head, right? So we would just check that if this dot head equals my target, that means I want to delete my first element. Okay, first element is 0. First element is 0. Suppose I want to delete 0. So the case will be actually, you would just say that if this dot head dot data, that means 0 is equal to the thing which I want to delete, that means the target, then you would simply move the head to the next. Okay, so you would just say that the next value, whatever is the next value is actually 1. So now the head will be pointing at 1, not at 0. Head will be now pointing at 1. So this 0 will be automatically removed. Okay, so this is the case when you want to delete the head. Okay, but if you want to delete an element in between, that means I have written this here. Okay, suppose this is the case and I want to delete this 2.5. So what I'll actually do is I would just say that now 2 will be pointing at 3. 2 will be pointing at 3. Automatically 2.5 will be ignored, right? So for that, you would just go inside the current. You would stop at the index before. Okay, that means you want to stop at index 2, not at 2.5. Suppose your target is 2.5. I want to delete 2.5, but I would stop at 2, right? I want to stop at 2 because I would directly point this 2 at 3, right? So simply you would say that if this dot current dot next equals target, that means if 2's next equals 2.5, yes, this is the case. 2's next. We suppose the current is at 0. Initially the current at 0. You would check that 0's next is 2.5. No. So again you will move the current. You'll check that 1's next is 2.5. No. 2's next is 2.5. Yes. So this is the case. You would just say that 2's next is equal to 2.5. You will just stop here. Else you are incrementing the current, right? Else you are incrementing the current. So that's how we'll do the things. Now just pass the condition which I have told you. 2's next is now actually equal to 2.5's next. Okay, that means equal to 3. So 2 will be pointing at 3 and automatically 2.5 will be ignored. Alright, so that's how you can perform the delete operation. It's very easy. Now we'll just break this. Okay, because we haven't break it. Okay, break it. Right, so we have breaked it. And one more thing, I think in the insert operation I haven't written break operation here. Okay, so what I'll do is after insertion of new node, just write the break operation so that the loop won't run after this. Time will be saved automatically. Okay, so just write the break operation if you just found the target and you have inserted things, and this is for the insert and this is for the deletion. So again, I want to delete 2.5. You can see I have displayed things, so I'll just say that my linked list dot, okay, sorry, I have to change the name, I think. So delete. Okay, so delete target. So here I would just say my linked list dot delete target. I want to delete 2.5 and let's display this again. All right, so let's try to run this, and I think I haven't displayed it yet. Okay, fine. So now let's try to run this. So if I run this, you can see that initially I have displayed it. So you can see my linked list is actually 0, 1, 2, 2.5, 3, 4, and 5. Got current dot next. Okay, the problem here is, let's try to get this. Hmm, 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 hmm. Okay, sorry. It must not be this dot current. It's actually current dot next. Okay, fine. So yes, fine. So you can see now things are fine. All right, so now let's try to run this. So you can again see 0, 1, 2, 3, and yeah, after this 4 and 5. So you can see 0, 1, 2, 2.5, 3, 4, 5. So this is the first case, but after deletion we want to delete 2.5. So now the new Linked list is 0, 1, 2, 2.5, 3, and 4 and 5. Okay, so delete hasn't been performed. Okay. Yes, it's actually performed. Yes, it's actually performed, but you would still see the deleted one. Okay, just a minute. You have the current here, right? You have the current here, and the problem which I created is right. So first of all, you have checked for the head, it's fine. And then in the body, you would just say this dot current dot next. Okay, sorry. We need to compare it with the next data. That means next value is 2.5 node, but 2.5 nodes data is 2.5, right? So we need to compare this 2.5 data value to the target 2.5, right? So now the things are correct, and now I think we can continue. Okay, so now I think it will work. So let's try to do this again. So 0, 1, 2, 2.5, 3, 4, 5. Okay, this is the first case. In the second case, you can see after deletion again we have displayed things. So again we'll check that 0, 1, and now you can see 2 is now pointing at 3, not at 2.5. Okay, so you can see that we have 3 here, 4 here, and 5 here. Okay, fine. So that's how things work. You can see we have successfully performed the delete operation here. Alright, so I hope you understood this, and that's it for this video. We have performed the operation append, we have performed the prepend operation, we have performed the insert operation, we have also performed the delete operation in our linked list. Alright, so I hope you understood this video. I have tried my best to explain this with the diagram and also with the code part again and again, but if you still didn't understand, please rewatch this video, and still you can ask your doubts in any of my videos. All right, so before ending this video, in the live chat you will find a link, or in the description you will find a link of a course provided by Geeks4Geeks. So if you want to learn DSA from beginner to advanced level, you can learn at this specific course. This is a very great course. It will take you from beginner level to advanced level. You can also check out the content of this course, and it covers everything required for DSA, not just for JavaScript, for any other language. Alright, so you can check out this one. So that's it for today. I will see you in the next one. Till then, see you, a good day. Bye bye.